All right, well, welcome to one of the last two lessons of this whole entire semester. Yay! You guys, we've almost made it. Just got two more to go. Well, these last two lessons are going to be based on word problems, so definitely going out with a bang. But these word problems specifically focus on how do you solve those triangles when they're not right triangles. You know, if they're right triangles, you can use that method of SOHCAHTOA. And I have written SOHCAHTOA right here. It kind of looks like that says CAT, so if it does, we all change that to an H, because we know that sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. Okay? Well, law of cosines is one way that we can solve a non-right triangles. The other one's going to be a law of sines, and that's going to be next lesson. Okay? But for right now, law of cosines. And in general, you know, just like always, you draw yourself a picture. When you draw yourself a picture, just label any of the three sides, A, B, and C. Normally we're used to having C as our hypotenuse, but since we're not dealing with the right triangle this time, we really don't have a hypotenuse. So just label any of the sides, A, B, and C. And then from there, always angle A is opposite of side A, or angle alpha is opposite side A. Angle beta is opposite side B. And this time, where we normally would see a right triangle, we're going to say angle gamma is opposite side C. Okay, now coming over here real quick to our first law of cosines right here. I need you to, there's a tiny little typo. That A right there should not be there. It should be BC. Okay, so if you can say 2BC, and then let's talk about this. All right, what happens is if you want side A, what it is A squared is the other two sides. So outside of A, the other two sides are B and C, so it's B squared, C squared, minus 2, and then what the other two sides were, so that's why it had to be a BC right there. Okay, so A squared equals B squared plus C squared minus 2BC, and the angle that goes with A is alpha, so that's why we have alpha in there. So it's times the cosine of alpha, and we do cosine because we're doing the law of cosines. Alright, so formulas 2 and 3 are just other alternatives. If I want B here, then the other two sides other than B are A and C, which I have A and C. So A squared plus C squared minus 2AC, and the angle that's opposite B is beta. C squared, the other two sides are A and B, and then the angle opposite C is gamma. And that's all you have to do for law of cosine, so it's actually a pretty simple one to memorize. Okay? Well, let's get into an example where we can use the law of cosines. We want to find alpha. What's given to us is side A, side B, and side C. Okay, since I want to find alpha, then the formula I'm going to use is A squared equals, because this A squared equals, when you have A on the left as you're equaling, you get to use alpha as your angle. So A squared is equal to B squared plus C squared minus 2BC times the cosine of alpha. Okay? So A is 3.3 squared is equal to B squared, so 4.1 squared plus 5.5 squared minus 2 times 4.1 times 5.5 times the cosine of alpha. Well, obviously, I'm going to get this term by itself. And all this out here in the front, that's all multiplied to it. These are just added and subtracted, so why don't we just move those terms over? And what I'm doing here is just being able to plug all this into our calculator at one time, so that's why I'm going through these steps. So 3.3 squared minus 4.1 squared minus 5.5 squared is equal to negative 2 times 4.1 times 5.5 times the cosine of alpha. Okay, to wrap this up, since those are all multiplied to the front of it, then what I'm going to do is divide them off. So negative 2 times 4.1 times 5.5, okay, and over here, negative 2 times 4.1 times 5.5. So what we have, by the time we cancel all those off, we have cosine of alpha is equal to 3.3 squared minus 4.1 squared minus 5.5 squared divided by negative 2 times 4.1 times 5.5. And remember, anytime I want to solve for an angle, like in this case, the only way I can get cosine off of this side and get rid of it is to use my inverse button. So alpha is going to be cosine inverse, and how about I just do that? All of that right in there. Okay, so we just have to plug this one time in our calculator, and let's go with degrees. We're going to write our answer in terms of degrees, and remember, we're finding an angle, so we don't necessarily want like 33.1 degrees. We want to convert it to degrees in minutes. So let's get our calculators, make sure it's in degree mode, and let's go about putting this in. And when I did this problem myself, what I actually got was, looks like 36 degrees, and rounding, let's call it 41 minutes. And so that's what angle A would be. All right, so you kind of get an idea of how to use the law of cosines a little bit. Definitely dependent on how many sides you have, that is for sure. All right, let's try this again then. We want to use the law of cosines to find side B this time, since it doesn't say alpha, beta, or gamma, it says B, which regular alphabet letters stand for sides of a triangle. So we want to find B when A equals 120, C is 170, and when they give us beta. So the formula would be, B squared equals A squared plus C squared minus 2AC times the cosine of beta. So B squared is A squared, which is 120, C squared, which is 170, minus 2 times 120 times 170 times the cosine of beta, which is 57 degrees in 10 minutes. So it looks like we're actually ready to type all this into our calculator. We're noticing that we're going to get B squared equals, so we're eventually going to have to take the square root of this. But remember, when you type that angle, what you can type in is 57 plus 10 over 60 whenever we're wanting to do that one. Okay, so let's put this in our calculator. And when I do this, I get a 21,178 point, I'll just write several of these out. And again, this is a B squared, not a B, so we need to take the square root of this and always do a plus or minus. Well, in this case, since we're finding the side of a triangle, we really don't need the minus part because that doesn't make sense. So we're really just going to kind of focus on the positive. So if we take the square root of this number, then what comes out is 145, let's say 0.5. We can box that up and call that problem done. Okay, we want to use the law of cosines to find gamma when A is 20.23, B is 43.43, and C. So we know A, B, and C, the sides. We want to find gamma, and the side that's opposite gamma is C. So our formula is going to go C squared equals, and then A squared plus B squared, so those are the other two sides other than C, minus 2AB, and then cosine of gamma. Okay, so this time, if nothing else, how about before we plug information into here, why don't we just manipulate the formula? So if my goal is to get that by itself, then let's move the A over. Let's move the B squared over first. So C squared minus A squared minus B squared is negative 2AB times the cosine of gamma. Let's get rid of those coefficients there in front of the cosine of gamma. And I get C squared minus A squared minus B squared divided by negative 2AB is equal to the cosine of gamma. Again, I'm solving for angle, so the only way I can get rid of cosine is if I do the inverse thing. So cosine inverse of C squared minus A squared minus B squared over negative 2AB is equal to gamma. Now all I have to do is plug in C as being 33.33 squared, A as being 20.23 squared, B as 43.43 squared. Okay, minus 2 times 20.23 times 43.43. All of that will equal gamma. We're finding an angle, so we want degrees and minutes. When I do this, I get gamma to be 47 degrees. And when I take that decimal and multiply by 60 and round it, it looks like 37 minutes. And there's gamma. All right. Now, of course, we have word problems. So what we're going to do is, if you'll take a second, if you'll go into the last section in your book, which is 9.5, and if you'll just pause the video for a second and read number 20. And by the way, thought just popped in my head. I'm using an older version of the book, which I think when we printed this out for y'all to buy, there might be the same numbering. I really think it is, but just in case there's off just a little bit, at least by doing these examples, like if I'm doing number 20, it might actually be 21. I'm not sure. I wasn't sure what happened when we did the last examples, but just know we're getting plenty of practice with this. So I'm pretty sure number 20 is 20, but just in case, let you know, there might be a little off, just a little bit. Okay, well, hopefully you had a chance just to kind of look at number 20 real quick if you paused it. I'm going to pull it up for just 2 seconds so we can read it a little bit of what at least I'm showing as number 20. But it says each side of a regular octagon has a length of 2.12 meters. And actually that was the wrong problem. I meant this one. I was in the wrong section, guys. I was in 9.6. That should be 9.5. But the lengths of the sides of a parallelogram are 7.2 feet and 5.5 feet. And if each of the obtuse angles, remember obtuse is larger than 90, of this parallelogram has a measure of 111 degrees and 10 minutes, what is the length of the longest diagonal of this parallelogram? Okay, a parallelogram, all that really is, glorified term for a rectangle slightly slanted. So we have this parallelogram, sides are 7.2 and 5.5. Okay, so let's draw ourselves a picture. Here's a parallelogram, here's my rectangle, slanted off to the side, and I've got side lengths of 7.2 and 5.5, and I think they said feet. Okay, and then obviously we have a diagonal that could either come this way, or we could have a diagonal that can go that way. Okay, one is connecting small angles right in here, and the other one is going from an obtuse to an obtuse. And it says in the problem that each of the measures of the obtuse angles, so the larger angles here, are going to be 111 degrees and 10 minutes. So the same thing up there. And it wants to know the length of the largest diagonal. So is the largest diagonal going from bottom left to top right, or from top left to bottom right? And I think that the longest diagonal obviously is the one coming across here. Okay, so we have a triangle. Basically, if you want to kind of cut it out like this, here's a triangle, just like that, where the length of this side down here is 7.2, the length of the smaller side is 5.5, and our obtuse angle is 111 and 10 minutes. And it wants us to find this, the length of the longest diagonal. Well, it looks like I'm needing to find a side. I know the angle opposite it, and I have the other two sides. So according to law of cosines, it says, okay, the side you're looking to find is going to be the sum of the other two sides squared. So 7.2 squared plus 5.5 squared minus 2 times those multiplied together, and then times cosine of the angle opposite the side that you're looking to find, which in this case is 111 degrees and 10 minutes. Okay, and all we have to do is actually plug all that in your calculator, and we'll get x squared equals to, I get 110.6877 and some other numbers. So that by the time we take the square root of that, what actually comes out, and I'm going to round to just like 3 significant figures. Let's go to 10.5 feet. And we can box that up. And just kind of go back to your problem, see if that makes sense. If I have a side that's 5.5 and a long side that's 7.2, doesn't it make sense that that length of that of the diagonal is going to be about 10.5? You know, if that was up around 200, might have a question about that. But since it's right around 10.5, it looks good to me.